In chapter 6, we're going to learn about these things called confidence intervals. And essentially, if you have a sample statistic, but you want a result about a population parameter, a confidence interval gives you a certain level of confidence to say that the population parameter is within this certain range that we're going to construct. So to begin, a point estimate is a single value estimate for a population parameter. The most unbiased point estimate of the population mean mu is the sample mean x bar. An interval estimate is going to be an interval or a range of values used to estimate a population parameter. Now, although we cannot assume that a point estimate is not equal to the actual mean or the actual population mean, it is probably close to it. So what we're going to do is to form an interval estimate. We're going to use the point estimate as the center of the interval and then add and subtract this margin of error. All right, and so we're going to get this type of interval here. Here's our point estimate in the center. It's symmetric about our point estimate, and then somewhere inside of this interval right here, with a certain level of confidence, we can say that our actual population mean is within this interval. So before finding a margin of error for an interval estimate, we should first determine how confident we need to be that our interval estimate contains the population mean. And that'll be specified in the problem for you. So the level of confidence is the probability that the interval estimate contains the population parameter. So the higher the level of confidence, the larger the interval is going to be. Now, from the central limit theorem, we know that when we have a sample size greater than or equal to 30, the sampling distribution of the sample mean is a normal distribution. The level of confidence C is the area under the standard normal curve between the critical values negative z sub c and z sub c. These critical values are values that separate sample statistics that are probable from sample statistics that are improbable or unusual. How do we find these critical values? We're going to need our z-chart for the positive, and we'll go through how to find the critical value when we're looking for a confidence level of 90%. First, let's draw a normal distribution here, and we're going to find the middle 90%. So this is 90% of the area, and if you remember, the area underneath this bell curve for a normal distribution, if you took the entire area, would equal 1. So 90% of 1 is 0.9. Now that leaves us with these two tails here. And since the whole area under this curve has to add up to 1, these two right here are 10%, or if you want to think in terms of decimals, 0.1. Which means this tail right here by itself, this shaded region right here, comprises of 0.05. Which means since the whole area has to add up to 1, the unshaded region, everything to the left, is equal to 0.95. And now what we need to do is we need to find the z-score for which, when you look at the probability z is less than the value we want, this y, it's equal to 0.95. So we come to our chart and we start searching around for 0.95. And we see that we have a 0.9495 and a 0.9505. Right? So that's in the 1.6 row the 0.04 column and the 0.05 column. So this y value, since we know that 0.95 is the average of 0.9495 and 0.9505, right, it is directly right in the middle of these two values. Our y value is going to be the average of the two z-scores that those two things correspond to. Equals 1.645. So just to recap, we have 90%, which has a decimal is 0.9. We look at the complement, the stuff outside of that middle range that we wanted, and that gave us 0.1. That's two tails. And so what we do is we find the upper tail by taking the remaining area and dividing it by 2. Then we find the area to the left. All right, so that is where we got the 0.95. We find 0.95, or the closest possible thing, inside of our positive z-chart. And we found that it was right in between 0.9495 and 9405. Right, so the value that we wanted is exactly the average of those two values in our z-chart. This came from the 1.64 spot. That came from the 1.65 spot. And so our confidence level, this is our z sub c, or our critical value is going to be 1.645. Now, if for some reason you don't have something that's directly in the middle like we had, you just take the closest one. We took the average because it's right exactly in the middle. For some very common levels of confidence, we have 80, 90, 95, and 99. And here are their critical values here. And notice that for 0.9 or 90%, we had the 1.645.